Okay. So let's see if we can get a decent picture. They say a ship is in an open ocean traveling 18 miles an hour on a bearing of north 64 degrees west. So let's see if we can get a picture. So I've got east, north, south, west. So there's a ship traveling north 64 degrees west. So north 64 degrees, a little more representative. So that is a 64 degree angle. My ship is traveling north 64 degrees west, okay? So they say it encounters a current of 4 miles an hour, okay? The ship encounters a current of 4 miles an hour, okay? And they say the current is acting in a direction of north 45 degrees east. So what I have to picture is, I've got to picture a second orientation system. So the ship gets here, and then there's a current that's going 4 miles per hour at a bearing of north 45 east. So north 45 east means the current is doing this. Okay? Where this is a 45 degree angle. So that's what the current is doing. Okay? And they say they want us to express the velocity of the ship. Okay? The velocity of the ship relative to the water. That's the important part of this thing. Relative to the water. So relative to the water means I've got to express the velocity of the ship based on this orientation and not this. If it said relative to the ship, I'd base my orientation here. But since it says relative to the water, I'll base my orientation here. Now, when I think about these vectors, okay, in this form, so V equals norm V cosine of theta I plus norm of V sine of theta J. Okay, when I think about that, well, that means that theta is a angle in standard position. So the initial side of theta is the positive x-axis, and it's measured from here. So now, think about this ship. Again, I want the ship's velocity relative to the water. Okay, relative to the water. So if I think about this ship on this 64 degree thing, right? So the ship's angle would go from here to there. From here to there. So the ship, theta would be 90, that's from here to here, plus 64. That's a 154 degree angle. So theta for the ship is 154 degrees, okay? The angle for the ship relative to the water, that's the key here. The angle for the ship is 154 degrees. I knew the ship was traveling 18 miles an hour. They said the ship travels at 18 miles an hour. So they gave me the magnitude of my ship's vector. So velocity, and I want to make sure we talk about the ship, okay? So again, the norm of V, cosine theta I, norm of V, sine theta J. Well, again, norm of V they gave me is 18. Cosine of theta, we just talked about it. That's cosine of 154 degrees I plus 18 sine 154 degrees J. That would be my velocity vector for the ship. Okay? And I could take you can take your calculator and you can simplify that. You could get negative 16.2 I. So this is approximation. That's the exact value, but they say we could round to 1 decimal. Negative 16.2 I plus 7.9 J. So this should be the correct answer. They didn't ask us for exact, they asked us to round to 1 decimal place. okay? But again, the key to this was I had to find the velocity vector for the ship relative to the water, okay? Now, part B says express the velocity of the current C in terms of I and J. So B express, they say, the velocity of the current C so they're going to call that current vector C, okay? In terms of I and J. Okay? Well, C is a little easier. For C, theta is right here, right? So vector C, and they told me that the current was going at 4 miles an hour, so the magnitude of C is 4. They gave me the magnitude for C. So it's going to be the magnitude of C, 4, cosine of theta is 45 degrees, plus 4 sine of theta is 45 degrees, J. I know what cosine of 45 degrees is, it's square root of 2 over 2. I know what the sine of 45 is, it's square root of 2 over 2, okay? And if you want to, you can take your calculator, 2.8i plus 2.8j. That will be the current vector, okay? All right. And part C asks us to find the true speed and bearing of the ship. Find the true speed and bearing of the ship. Okay? Find the true speed and bearing of the ship. Well, again, if that's the ship vector, this is C, then this vector right here would be the resultant vector. So I'm going to say that the resultant vector would just be V plus C, and that's just going to be adding these two vectors up. So negative 16.2 I plus 7.9J, that's vector V. Vector C is this, so plus 2.8I plus 2.8J, okay? If you do that, you'll get negative 13.4I okay? And they say plus 10.7J. So there's the resultant vector, okay? And so that's, well, they asked me for the speed though. They say find the speed. That's the resultant vector, okay? But the speed will just be the magnitude of that vector. So I've got to find the magnitude. Well, again, that's just the square root of these coordinates squared. Do that in your calculator. 17.1 miles per hour. Round to one place. That's the speed. Okay, that's the speed. All right. Well, as far as the direction, okay, okay, remember that equation, tangent of theta is equal to y over x, okay? Tangent of theta is equal to the b component. You could call it b over a if you want. So tangent of theta will be b over a, right? That over that, right? And then take the tangent inverse and you'll get approximately 141.4 degrees. degrees. Okay. When you do that in your calculator, well, I've got to remember that tangent is defined in, they say for theta in quadrant 2, we have theta equals tan inverse of negative 10.7, over 13.4 plus 180 or 141.4. So since that's in quadrant 2, this thing would have a bearing. Let's think about what that means. Theta is 141.4, so I do a 141.4 angle here. That means that this angle right here is 51.4 degrees. Because remember, the bearing, I've got to have north 51.4 degrees, and this would be west. So there's my bearing. If theta is 141.4, then that means that this acute angle must have been 51.4, because 141.4 minus 90 is 51.4. Okay. All right, I will let you do example 10. We'll do example 11. Example 11 is on page 736. Okay. And I'm going to ask you to read it. I'm not going to write all that. So read in text. It's just too wordy for me to write it all. I'm going to show you what it is. They say 3 forces, F1, F2, and F3 act on an object. So we're going to draw the picture. So we've got some object, okay, sitting at, suppose, the origin. There's a force 32 degrees from horizontal acting on that object. This is 32 degrees. There's a force F2 acting on that object. Okay. And finally, there's another force, F3, where this is an 18-degree angle. So there are 3 forces acting on this object. F1 is acting here at an angle of 32 degrees from the horizontal. There's a second force acting like this. So again, I can think of this as the x-axis, that is the y-axis. Then this third force is acting on the object at an angle of 18 degrees. So they want me to write the resultant force in terms of, and they give me the magnitudes. Magnitude of F1 is 60. So F1 magnitude equals 60 pounds. F2 magnitude is equal to 100 pounds. And F3, they say the magnitude is 85 pounds. So they give me the magnitude of each force. Okay, they give me the magnitude of each force. And they want me to find the resultant force. So find resultant force. So when I apply all 3 of these forces, tell me what the result is. Give me a 1-vector answer. If I apply all 3 forces, that's equivalent to what 1 vector acting on this object, okay? Now, I'm gonna have to basically write down formulas for F1, F2, and F3. So F1, and again, remember, it's always based on an angle from the positive x-axis. So there's theta 1, the angle for F1, okay? There would be theta 1. Well, I gotta think about this. This is a 32-degree angle, and this is the horizontal. 180 minus 32, 180 minus 32 is 148. So that means that theta 1 is a 148-degree angle. So F1 would be the norm of F1. They gave me that is 60. Or cosine 148 degrees I plus 60 sine 148 degrees J. Got to do the same thing for F2. F2, so theta 2 would go from here all the way to there. There's theta 2. Well, that's a flat angle, so that's 180 degrees. So theta 1 was 148 degrees. Theta 2 is 180 degrees. So theta 2, F2 rather, the magnitude is 100, so I'll have 100 cosine of 180, I, 100 sine 180, J. That's how I can represent F2. And finally F3. F3, so let's figure out what theta 3 is. Well, theta 3 would be the angle all the way from here to there. That would be theta 3. So since this is an 83-degree angle, the best thing might be to do is figure out what the rest of that is. 90 minus 18, 72 degrees, okay? So 360 minus 72, or you can think about this as 270 plus 18, right? Because from here to here is 270 plus the other 18. 270 plus 18 is 288. So we have 3, magnitude was 85, so 85 cosine 288, I plus 85 sine 288, J. Okay. So all I'm going to do is simplify these things, right? I can simplify these things. You can just take your calculator and do this, and they say you get approximately negative 50.9 I. And then they say plus 31.8 J. Simplify up 2. They say you get negative 100 I. Because the sine of 180 is 0, if you remember that from your unit circle. So this one goes away. And it's really just that one. The cosine of 180 is negative 1, so that's why you get negative 100 I. And then finally simplify this one with your calculator, negative 124.6 I minus 49J. And then so my resultant vector will just be F1 plus F2 plus F3. And all you're going to do is take this plus this plus this. Add up corresponding components. So you say negative 50.9 minus 100 minus 124.6. That gives me, negative 50 point, one of them should have been positive. Yeah, F3 was 26.3. F3, I did this wrong. F3 was 26.3, I'm sorry. I wrote down R. F3, if you do this stuff right here in your calculator, F3 turns out to be 26.3 I. And they say minus 80.8 J. And when I say it was correct, you take this plus this plus this, and that's how you'll get that resultant vector. And that's where that negative 124.6 came from. And then minus 49J. That would be the resultant vector. Okay, that would be the resultant vector. All right, that's example 11. I will leave example 12 to you. If you get stuck on any examples, let me know. I can work them out for you and send it to you. I don't mind. But they all work kind of the same way. So if you get stuck on it, let me know. Otherwise, this concludes section 7.4.